My thesis statement: Human activity is causing acceleration of the climate change cycle. Filmed by Mr. Pizarnik. So, do you believe in climate change? Hold it. This is science, not religion. It's not about beliefs, it's about facts. We must look at what is supported by data to form a conclusion. Remember, science is what we think we understand.
The science guy who believes in man-made global warming.
Yeah, that's right. More often than not, it's Bill Nye the Science Guy versus some dude. And when you look at the screen, it's 50-50, which is inherently misleading. If there has to be a debate about the reality of climate change, and there doesn't, then there is only one mathematically fair way to do it.
Last Week Tonight presents a statistically representative climate change debate.
Good evening. Joining me tonight, a climate change denier and, naturally, Bill Nye Science Guy. Bill.
John?
Yep.
Humans are causing climate change? No question.
Wait. Before we begin, in the interest of mathematical balance, I'm going to bring out two people who agree with you, climate skeptic, and Bill Nye, I'm also going to bring out 96 other scientists. It's a little unwieldy, but this is the only way you can actually have a representative discussion. Please file in. Again, this is going to make the debate difficult. We shouldn't really be having it in the first place. But representationally, climate skeptic, please make a case against climate change.
Well, I just don't think all the science is in yet. It's settled.
Okay, and what is the overwhelming view of the entire scientific community? Okay. Any response to that? Any response? I can't hear you over the weight of scientific evidence. This whole debate should not have happened. I apologize to...
Scientists agree climate, past and future, is changing. The climate is always changing. Climate has always changed and will always change. The question is, how much, how fast, and how come? In this graph, you can see that the temperature fluctuates a great deal in the United States. This graph only goes back to 1901, but it is clearly evident that the warmest years have occurred in the last 2 decades.
Does the scientific community feel that global warming is decreasing or increasing?
Yeah, like a lot of people ask me, like, has there been a pause in global warming because like temperatures aren't increasing as fast as they were a decade ago? And I always say, pause are for kittens and puppies because global warming is definitely still increasing. We're still getting more heat trapped into the oceans. The oceans are sucking it up. And sea level's still rising. Look at the sea level record for the last decade. It's going up like gangbusters, hasn't slowed down. So, is there a pause in global warming? No, there's not really a pause in global warming. Sometimes there's natural fluctuations and we warm up a little faster in one decade and a little slower in another decade. But global warming, human-caused climate change, that's definitely going right on up in there. We haven't slowed down at all.
So how does CO2 cause global warming? We know about the carbon cycle, and we can see that there's a great deal of carbon stored in the fossil fuel sink that's now being released by humans burning the fossil fuels. But how does CO2 cause the Earth to get warmer?
learning lesson, one of the NOAA websites. So you start with 2 clear soda bottles and partially filled with water. I filled them about halfway with water. And you need to have a stopper. I use the rubber stoppers I got from chemistry lab, but you could use even a piece of clay or a piece of tape over the top. Then you want to have a thermometer for each. Ideally, you could use just a plain glass thermometer, sit in there. Or I like using these digital Vernier GoTemp, which I can just monitor on the computer, and that's what I'm going to do. So then you need a lamp, a heating source. And the idea is that one of them, we're just going to put the stopper on it, and we'll stick the temperature in here, the probe in there, and now it will record the temperature of the gas in there. Now the second one, we want to develop some CO2 in the bottle to see the effect on the temperature, change in temperature of the atmosphere as it's heated. So what we're going to use is these Alka-Seltzer tablets. I bought the cheap ones from Walmart, but they should work fine. And so I'm going to stick them in there, and they will effervesce, and they will. Okay, hopefully you can see that. Now I'm going to put the stopper on here, and I'm going to stick my temperature probe. Okay, tight, and now I'm going to turn the lamp on, and I am going to observe the temperature for an hour. I'll just come back in an hour. I will shut this video off and turn it back on, and we'll see what the effect of the temperature of the gas in each bottle is. Stay tuned. Well, welcome back. It's been almost an hour. This this demonstration is about over. You didn't need to wait an hour, but my temperature change for the approximately 40 centimeters that I had from this light bulb to these bottles was 9 degrees Celsius, warmer in the bottle with the CO2. Obviously, that is the carbon dioxide is having an effect. Variables in this obviously would be the wattage of your light bulb and how close you are to it. But I think the point is very easy to demonstrate with very simple equipment. Students could do at home, but I think it'd be very effective to do at the beginning of a class or a lab and at the end of the class, even a short class. And this is stuff that's readily available. I bought the Alka-Seltzer from Walmart. Good luck.
Okay, so we can see that CO2 does cause more of the heat energy or heat to build up inside of the atmosphere in the bottle, just the way it would work on our atmosphere. Atmospheric carbon dioxide also has an effect on plant life. We can look at plant life and observe different plants grow differently with changed amounts of CO2. Just like some plants will actually grow better with CO2 higher levels, and other plants will actually die out with CO2 at higher levels. Now you may be saying to yourself, that doesn't sound right. Plants need CO2 to grow. And you're right, but they also need water. But it is possible to kill certain plants with too much water. Other plants, if you overwater them, they're fine. So Iowa State University did an experiment, and they found that the plants that grew with the highest level of CO2 was poison ivy, and the plants that grew the worst with high levels of CO2 was eucalyptus. Eucalyptus is the main food source, or the only food source, for koala bears. This is also why many other species that depend on eucalyptus are struggling to survive, and why in the United States we are seeing an outbreak of high density poison ivy growing in the forests. But we all like our citrus and our sandwiches, and we like to have our breakfast from 1,400 miles away, especially if you have oranges. So what effect is this global warming going to have on humans? After all, we're creating our own problem.
How does climate change affect humans?
There are four really important ways that climate change affects humans. Number one, as the planet warms up, we're going to redistribute rainfall, which is going to affect our water resources, and parts of North America may get a lot drier. Number two, as the polar ice melts, sea levels are going to rise, and a lot of people and a lot of the world's major cities are right on coasts. That's going to impact them. Number three, things like the species distributions, where we can grow food, they are going to change as the planet warms up, and so the range of which way you can grow corn and things will change. Number four, the oceans are going to get more acidic as more CO2 dissolves in them. There are untold ramifications from that. There are the possibilities of radically altering the food web in the ocean, which can affect everything from the composition of the atmosphere to the ability of the oceans to provide food for us.
The link between greenhouse gases and temperature is clear. It's also clear that humans are putting millions and even into the billions of tons of CO2 into the atmosphere by burning fossil fuels. But who uses most of this energy, and who's burning most of these fossil fuels? Well, unfortunately, the United States leads the charge with much, much higher CO2 emissions per capita than any other country in the world. We can see that the atmospheric CO2 is rising, creating warm periods, and we can also see that when it's low, we have cool periods. Unfortunately, this is our current level, higher than anything we've ever registered before. But it's a vicious cycle. As the population grows, climate is changed because of our needs. Also, our need for agriculture increases to feed all these people. So, the more agriculture we have, the more population we can support, the more we affect the climate. It's a vicious cycle, but who's going to break it? And some people say, what about volcanic eruptions? They release CO2. Well, Mount Pinatubo erupted June of 2001, which caused measurable change in temperatures and acidity of rain for 3 years. Estimated 15 million tons of sulfur dioxide and carbon dioxide were released into the atmosphere by this eruption, but it was still considered a short-term change. If the sea levels rise due to our consumption of fossil fuels, over 70% of the population will have to move. But the sea levels have been high before. We can actually go to what's called the fall zone and see where prehistoric ocean coastline existed. So, do people change the Earth's climate? I would have to say yes. There's a lot more to climate change than simply temperature and rain. Thank you for your time. I hope that you enjoyed my presentation. Now, go get working on yours.